Welcome back, everyone. We're into 13.4, and I know that this week we owe you some time because the last lesson was so lengthy. And like we said, we're trying to honor your time in this remote learning, so I'm going to make this quick. Things that I suggest you have available to you as we go into 13.4 are your 3 handy-dandy sticky notes with your parent functions for sine, cosine, and tangent. This isn't really a new lesson. It's just an extension onto what you all worked on from earlier in the week. We looked at these functions in terms of parents, and you guys in your last practice set had to transform them with scale changes and also reflections. So we're just going to add a little piece onto that. One thing we haven't looked at yet is translations. So as you found out, scale changes are going to stretch or shrink, stretch or compress in terms of how quickly the function unfolds or how quickly the function increases and decreases. Transformations are going to be shifts. So whether or not this parent function shifts vertically or whether this parent function shifts horizontally. So we're going to be looking at shifts, which we've been doing all year long. Again, same things apply. So have your little sticky notes available. The first one we're going to be looking at is sine. I'm only doing 2 examples, and I'm trying to keep it to 13 minutes. And that's it. I'm sure I'll figure it out. Okay, so the first one I want to look at is example 1. So again, we're still looking at these parent functions. And we are just going to see what happens. Let's call it f of x equals 3 times the sine of 2x minus 1. All right, so we've got a lot going on here. Our focus for this particular piece is that we are not going to do anything more than 1 period. So for now, because our focus is going to be kind of this crazy transformations, we're just going to look at 1 period of the function. So as I look through this, I'm just going to try to make sense of what's going on here. I'm just going to go, usually I start with the inside because I tend to forget inside, input, inverse. So I'm going to start here while that's in my mind. So remember, the inputs for my sine function discuss the period of the function. So as I look at my parent function here, the period of this function as the parent is 2 pi. However, inside it's telling us 2 times x. Well, we need to undo what's being done to x. So instead of multiplying this period by 2, we're actually going to divide this period by 2, which means instead of unfolding in 2 pi, we are actually going to only unfold in pi radians. So this is going to affect the period, which is going to be pi. And this is what you guys worked on last time, and hopefully you attended the Zoom if you were struggling or just to say hi. Looking outside the function, we've got 2 things going on to our outputs. Here, I can tell that my outputs are being multiplied by 3. So I'm going to have a vertical scale change by a factor of 3. And as you know from your sine curve, this is going to affect the height of your wave. So instead of having a vertical height of 1, this is now going to have an amplitude of 3. So already we're knocking out some of our important essential pieces. And then this whole thing is going to be translated down 1. So this is the new piece today. Vertical translation down 1. So this is kind of our new thing. What happens if this... Woo! Sorry. Dog. So what happens if this whole thing goes down 1? He's going to keep doing that until whoever it is that walks by stops walking by. Russie, stop. What are you doing? Oh, I see it. That's the trouble. Again, I'm in my little makeshift home office. There it is. Adorable. Okay, so, sorry. Focus on 13 minutes. Okay, so... this whole thing is going to be translated down 1. So once we transform all this stuff, we're going to take this whole thing down 1. All right, well, actually what I'm going to do, because I'm lazy, and not only lazy, but I also want to, complete my mathematics as quickly as possible so I can use whatever graph this is to analyze my function or whatever situation I'm analyzing. And I just want to get this thing done So what I'm going to do is I'm actually going to, in lieu of making a table for all of this stuff, I'm just going to build my building blocks as usual. So what I'm going to do here is I'm looking at that parent function. I'm going to go ahead and make my sign. Now, before I build anything like my amplitude, my period, is I know I need to move this midline. My midline is typically happening at 0, but this time I need to move it down 1. So I'm going to take that whole midline and I'm going to shift it down 1. So here come my highlighters. All right, I'm going to shift that whole thing down 1. So that takes care of my vertical translation right there. Now I'm going to move forward just like before, and I'm going to handle the period of my function, which unfolds to pi. Now, usually I make my little tick marks here, and I'm going out all the way to pi. But you know what? I'm going to transform right down to my new midline. There's my pi. Here's my 0. All right, well, in order to build sine, I have to go halfway. Well, half of pi is half of pi. Half of that again is pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4. Alrighty. So now I've already handled my vertical translation down 1. The period to unfold is just going to be pi. And now I need to handle my amplitude of 3. All right, well, if this is the midline, an amplitude of 3, my height is going to go up 1, 2, 3 units, which means instead of being up at 3, I'm actually going to increase all the way to a value of 2. And I'm going to go down 3, 1, 2, 3. But 3 back from -1 actually puts me down there at -4. My building blocks are there. I'm ready to roll. I'm going to start my 0 right here. Again, pencil's great. I'm going to increase to 3, decrease to my new 0, decrease to -4, and increase again to my new 0. So that here is my function, sine transformed, vertically, horizontally, and scale changed. There we go. All right, so we already have the period, we already have the amplitude. Let's look at our range a little bit. Our range for f of x is going to be, it is going to exist from -4 all the way up until 2. Kind of cool. This vertical translation is also called a vertical shift. All right, so that's one thing that you might see, that midline moving up and down. Midlines are usually kind of not a big deal. Where it is going to kind of, that would be a vertical shift. So now I'm going to attempt a horizontal shift, and that gets a little trickier because as we're shifting through these fractions of pi, that's where things really get just a little bit more challenging. All right, so here we go. Example 2. I'm doing 2 examples today, and then that's it. So I've got f of theta, -2. Oh boy, I've got a vertical reflection there. That's going to be interesting. And I'm going to handle a cosine. And this time I'm going to have theta minus pi inside my function. Okay, so I'm going to need this. Let's make a little bit of sense here about cosine. So one thing I know I can handle is this is going to change my amplitude. All right, so I'm going to make a little note about that. Instead of increasing to a height of 1s, this is actually going to make an amplitude of 2. Okay, it's going to grow 2 times faster. This is not only going to have an amplitude of 2, but it's also going to be 2 reflected. Oh my, reflected. Geez, Miss Moore. Okay, so instead of starting up at 1 and traveling, decreasing, this whole thing's going to be whoop. So we're going to start low and increase when we unfold our cosine. All right, well, no big deal. We've been down that road before. Now I'm going to go ahead and look at multipliers on my input. There are no multipliers on my input, which means my input has not grown or shrunk. So the period of my function has not changed at all. Period is still going to unfold in 2 pi. However, the difference is that as it unfolds 2 pi, this whole thing is going to be translated where? Inside input inverse. You're subtracting pi. So in order to undo that, you're actually going to add pi. So this whole thing is going to go whoop, translated to the right pi units. And we actually call this, instead of horizontal translation, we're going to call it a phase shift. So it's going to be shifting phases, phase shift of right pi. It's a little bit new phrasing, but it's the same general concept. Okay, so here's how I would build this one. I keep my little cheat sheet there. And I'm trying to, before I do anything, especially me and my pens, I really want to see, I don't think I'm going to need anything left of the 0. In fact, I think I'm going to need things more to the right of my 0 line. It is going to have a little bit more vertical height, but that's okay. We can label anything we want. All right, so I want to make sure I have enough to the right for my function. So that midline doesn't need to move. So we're going to keep our midline exactly the same. We can handle our amplitudes. Instead of labeling this 1, I'm just going to label it 2. Why? Because I can, because it makes it easier. There's my 0s, there's my 2s. Okay. We'll handle the reflected piece in a minute. So whenever I move something personally, I like to set up the original just to see if that makes my life a little easier. So I know I'm going out to 2 pi, and there's my pi. Pi over 2. I'm getting so good at this. That's really, you know, no great shakes. So that's where my old function used to be. And sometimes I even like to make little pencil marks. So before I shift this whole thing to the right pi, okay, well, what did it used to look like? Well, negative reflection, it's going to start down here. It's going to move up, and then it's going to move back down. Now, I could move that whole thing over. All right, let's try that. Instead of starting at 0, I'm going to move this whole thing to the right pi. So really, pi is going to be my new 0. Okay, well, if my beginning thing moved to the right pi, now my end point needs to move to the right pi. Okay, well, if I move to the right pi, now I'm here at 3 pi. Okay, no big deal. Probably going to need a little extension here as one of my important points. So once again, oh man, what fraction is that going to be? I don't even know. Okay, so count. 3 pi over 2, 4 pi over 2. You got it right. 5 pi over 2. Okay, so now my whole period of cosine is going to unfold in between those marks right here. All right, well, cosine usually starts up at 1. This whole thing is reflected. So my new cosine is going to start here, down at -2. There's that multiplier. Then it's going to travel through my 0, up to its greatest point, down through my 0, to its lowest point again. And we're going to keep that curvature. And there is one period of my new function. Now, you know, I could continue it back or forward, whatever the case may be. So the only thing that changes here is my range is going to be -2 to 2, inclusive. We're good to go. Ha! 13:15. I seriously nailed 60 minutes, so I'm not going to, you know, keep going. So just bye. Homework problems, good luck. 2 of them are kind of weird. C and D, excuse me. Number 1, C and D are a little bit challenging. So, you know, if you struggle, you're not out of line. Goodbye, little ones.